Welcome to this webinar. The webinar called the Post-Quantum Cryptography Transition, Tackling a Huge Challenge. And this webinar is co-organized by AFNIC, the .fr Registry and Research Center in France, and the Internet Governance Forum Dynamic Coalition Internet Standards Security and Safety, or IS3C. My name is Walter Natus van der Borgt, and I'm your host and moderator for today. And I'm a consultant on internet governance and cybersecurity based in the Netherlands and the coordinator of this IGF Dynamic Coalition IS3C. We have collaborated with the UN IGF Secretariat who host this webinar, for which we are very grateful. Why this webinar? Late in 2024, AFNIC commissions IS3C to write a report on the technical, political, and social implications of the advent of quantum computing. This project was led by Elif Quizao-Cortez and João Moreno Foucault, and they presented the outcome at the Internet Governance Forum in Lillestrøm in June under the title The Social, Political, and Technical Impacts of IoT and PQC Policies. IS3C and AFNIC agreed after the publication of the report that no matter how much traction it got, and it did, would not be enough, and decided to enter a second phase, aimed at turning the theory of the report into practice. The webinar is the second manifestation of this phase. The first was a call for experts to join two working groups regarding PQC, one for the DNS ecosystem and one for the routing system. And I will return on this topic later on in this webinar. But first, let's focus on what has been and what is coming ahead. With me today are 5 speakers: Pierre Boni, Benoit Ampol, Santosh Balakrishenan, João Moreno Foucault, and Nicolas Fiumarelli. I will invite them all individually before they start their presentation. You will be invited to pose your questions after the final presentation. And after this round, I will return with news on the working groups and the plans ahead, and then there will be a second round of questions. But first, let me introduce, with further ado, Pierre Boni. Pierre is the Director General of AFNIC and will give you an overview why this topic is so important. Pierre, the floor is yours.
Thank you very much. Hello, everyone. My name is Pierre Bonis. I'm the CEO of AFNIC. AFNIC is the registry for .fr, other things, but mostly known for that. And AFNIC is engaged in several research and development activities. And one of those is about the post-quantum cryptography. Let's once again thank you all for your time, for participating to this webinar. And a very big thank you to Wout de Natris for his relentless job on that IS3C initiative. We are very happy for several reasons to be here today and to participate in this initiative. I would maybe point out 2 out of the very numerous reasons why we are happy. The first one is that IS3C is a dynamic coalition. And we are convinced at AFNIC that the dynamic coalition approach within the Internet Governance Forum is one of the most concrete initiatives taken years ago to prove that IGF is not only one time in a year where people gather in a very nice city and fly from one workshop to another and then go back to their office. The dynamic coalitions are the living proof that when we stand together and share a diagnosis about what we think is a challenge or a problem, the IGF is a place where we gather and decide together to work all year on these problems. So this is very interesting for us to participate to such an initiative. The other reason why we are happy to work on that is that maybe thanks to the discussion we have within IS3C and to the discussion we have with our colleagues, and maybe also heard it because we are doing our own research on that, we are very much convinced that this is one of the biggest challenges we have to face today within our own day-to-day work. As AFNIC is a registry and is in charge of the domain name system under the .fr and for other extensions. And because we are engaged, of course, as you know, in DNSSEC for, I think, something like 20 years now, more or less, we would face a huge problem if we would not be prepared to the post-cryptography that is arriving. So this transition is now, and we are very much aware that the transition that everyone knows are necessary or useful doesn't make this transition easy or fast. And the best example I think everyone knows in the room is IPv6, which is a vital transition since I was born or something like that. What is nice is that there is still a huge room for progress with IPv6. So every year we can be happy to see that there are progress. But the transition is lasting more and more, and maybe we'll be retired before the transition is ended to IPv6. This is a kind of luxury that we cannot afford with the post-quantum cryptography transition, because we face some challenges today, and I'm very sure that we're going to talk about it today. But if we are not really, not in 10 years, not in 20 years, but almost tomorrow, we are in danger of people taking advantage of our unreadiness today to harm us in 20 years. This is something we have to discuss. This is something we work on within the IS3C. This is also something we work on within the Conseil Scientifique of AFNIC. And for those who are interested, there are some small videos that go back to our last days of the Conseil Scientifique in Benoît. And the topic was this one also. So I just wanted to share that. I'm going to be too long. There are much more things to say, and experts are going to speak now because I'm not one. I just wanted to thank you all. As I said, Wout and the R&D team, Benoît, Sandosh, for their work on that. We're very proud to be part of the journey. So have a nice webinar, and I hope it will be one of the first webinars that we will have later, and that we accelerate this transition. Thank you.
Thank you, Pierre, and also for your kind words on the work that we have been doing. And also, I think that the collaboration between us has been fantastic and is leading to results. So I think that is the more important conclusion. But this also go in a very collaborative and fine way. So thank you. The next person who's going to speak is Benoît Ampol. And Benoît is Director Partnerships and Innovation and the head of AFNIC's Research Lab. And he will go deeper into the topic with a focus on DNS and routing. Benoît, the floor is yours.
Thank you, Wout, and thank you, Pierre, for the introductions. So, good day, everyone. Thank you for joining us today to address this critical challenge for the internet infrastructure named the post-quantum cryptography. Before diving in, let me start with a quote I found by the physicist Richard Feynman. So, if you think you understand quantum mechanics, you don't understand quantum mechanics. So, this captures the fascinating complexity of the quantum world that, unfortunately, I will not address here today. But it's important to understand that if quantum physics could fascinate, post-quantum cryptography protects. So PQC acronym is a security upgrade for the internet, not quantum physics, and it's a technical transition to counter a future threat. So even though Pierre just mentioned why this is matter for why we care as AFNIC, our core mission is to manage the .fr and the DNS infrastructure in France. And so in addition to our day-to-day work as a critical service operator, we have also other commitments as a multi-stakeholder organization. So to engage with them, to conduct technical and research work and coordinate within our ecosystem as well. So this is the core reason why we joined also the IS3C Dynamic Coalition, starting last year, funding the PQC report you mentioned already. And we were very happy with the outcomes last year, and we are very happy to follow up again this year. So this multi-stakeholder dialogue is also a very good tool to process and address the PQC collectively. So let me just set up the scene. Now that I've presented why AFNIC is involved on this topic, let me also give you a quote from Vincent, the General Director of the French National Security Agency. He has provided a few days ago during a radio cast. It was very interesting and very simple to understand that we should consider that this is a digital equivalent to have a universal master key that open all the doors. So this is not an exaggeration. This is when a sufficiently powerful quantum computer will exist, it could collapse, and it will collapse, today's cryptography mechanism, such as ERISA, elliptic curve, so forth and so on. So from a security and trust perspective, this is a major threat for the internet. Yes, like you mentioned also, it is not for tomorrow, maybe in the next decade, but we need to be prepared, and that is why we must act now. On one end, quantum computing will bring revolutionary advances for sure, extraordinary computational capabilities, major scientific progress, and I think we should collectively welcome this innovation. But on the other hand, it forced us to take this new risk about cryptography very seriously right now. There's no need to panic, but as AFNIC, we believe, and as a group in the Dynamic Coalition, we believe that it's our responsibility to raise awareness on the topic and to take steps to prepare. Here are some PQC strategies examples. There's others, but it's interesting to compare them and to keep on some attributes. So at the French national level, the National Security Agency is asking for having a three-step approach, which is very straightforward but meaningful, like doing a cryptographic inventory of your assets, identify your critical system, and begin to prepare a transition plan. So the agency set clear milestones. From 2027, which is not so far from now, PQC integration becomes mandatory for security product qualification, and by 2030, acquiring non-PQC solutions becomes to be unacceptable. In the US, the NIST also explicitly recommends starting transition planning immediately. Based on the Mosca theorem, I think experts after me will also explain it, the store now, decrypt later threat, attackers collecting encrypted data today to decrypt them later. They both recommend hybrid approach, also combining classical and PQC algorithm to ensure security continuity and avoid any regression during transition. So the universal message and common message here is the transition must start now. Why does this take time? You mentioned IPv6, Pierre. Cryptography is not, and the transition is not swapping algorithm overnight. We know this. Cryptography is everywhere, omnipresent, implicit, deeply embedded in heterogeneous and diverse components, including legacy systems. So it's a progressive architecture transformation. Taking our DNS stats on the .FR zone, the first results are clear. Signing times are 5 to 10 times slower with PQC algorithm. Zone files, which contains DNS data, become significantly larger. Computing, storage, and network resources are much more stretched. Think about constrained computing environments. At the scale of large technical infrastructures, such as the DNS, these cumulative effects show PQC transition cannot be treated as a simple technical change. So where do we stand? On DNS, we tested multiple algorithm PQC on the entire zone, quantifying performance on routing. Some research also shows that it's viable with account optimization. So beyond experimental results, as an example for AFNIC, we have identified different work streams. Standardization for sure, hybrid signatures, hardware security, module readiness maturity, resolver readiness, authoritative server impact on ecosystem coordination. This requires essential collaboration with startups such as IATF, also multi-stakeholder coordination with registry operators, internet registries, and shared learning across the ecosystem. And what is the path forward? In a decade, a lot could be done. Look at the timeline: 2027, 2030, and 2035. These dates reflect the reality of a long, collective, and hopefully global transition. To us, our vision is to anticipate without rushing. PQC does not demand brutal disruption, but a posture across the entire ecosystem. Maybe with more caution than previous technical transitions, such as IPv6 or even DNSSEC in the scope of DNS, we must think long-term security, surely isolate temporary compromises, and work with also evolving standards. So there is no one-fits-all solution. Multi-stakeholder coordination is essential. Our principles are clear: test early, share openly, and standardize together. This will, I think, ensure transition without weakening internet security and trust. Thank you.
Thank you. I think you've shown us how big this challenge actually is and what the steps are that we can take. As already said, that we have done a research already about a year ago, and we published it in June and presented it in June at the IGF in Norway, in Lillestrøm. And one of the co-writers of the report is João Moreno Focal, and he's a cybersecurity expert in Brazil, vice chair of IS3C Working Group 9, and co-author of the report. And he will share with you the outcomes of the report and his recommendations. João, the floor is yours.
Hello, Wout. Thank you. Thank you all for being here. It's a pleasure to talk to you. Well, just to quickly speak about me, I'm an electrical engineer. I worked as a cryptography researcher a couple of years ago. I'm a cybersecurity professional, and I also do public policy consultant work. So my main goal here is to give you introduction to PQC and also to show the highlights of our research. And to start doing that, I would like to explain a bit about cryptography. Have these new challenges with the quantum computer. To understand this, the first thing is that we must know that cryptography relies on mathematical problems. So if the mathematical problems are too complex for today's computers, we remain secure. And one very simple example is on if it's secure enough is when we look at the Caesar cipher, which was a cryptography scheme during the Roman Empire. And this scheme just switched letters. So if you were going to write a letter, you would switch the letters order. And this was enough to protect the communications from generals to the central power. And this actually happened because 90% of the population was illiterate. And it is very clear that when we build these kinds of devices, we think of the reality we face now. And if this new challenge, this mathematical problem being used by cryptography is simplified and computers become capable of attacking the crypto system, we must replace it immediately. And when we go to what is post-quantum cryptography, we need to go back again and think of what is being attacked by the quantum computer. Most of the asymmetric crypto systems rely on two mathematical problems called factorization and discrete logarithm. This means that it's pretty hard to a computer to factor a huge number or to discover their logarithm. And even though we think this is pretty simple when we do like pen and paper in small numbers, when we get to huge numbers, this becomes a really challenging task. And for a number used right now in crypto systems would take the age of the universe squared to be able to factor these numbers. Well, you might think, okay, so the age of the universe is definitely secure enough. But when the quantum computer comes, this new set of computers, they leverage the quantum superposition, which is a very interesting phenomena. And when a quantum computer uses this phenomenon, they can parallelize the attack of trying to factor a number. And this has a huge effect. You can downgrade the security in several orders of magnitude, making something that would take the age of the universe to take just a couple of minutes. But this algorithm needs a quantum computer to be able to run it. And when we look into the world right now, we can see several quantum computers already being active, but they aren't still powerful enough to be able to factor this number. And if they aren't right now, why to move? And well, we are in a very narrow limit on a new breakthrough breaking these crypto systems. And with this, we know we need to act fast because, for example, when the SHA algorithm was simplified in 2017, they managed to do an attack that would require 100 really powerful computers to process for 1 year to be able to manage this attack. And with help of Google and their supercomputers, they were able to break this. So the scale of these kinds of attacks, if you have the right hardware capable of running, can change everything in a very short period of time. And this is why we dropped SHA in the past few years. So thinking of this, what we researched here, we focused on how governments were handling this modification to really leave quantum unsafe protocols. And we looked especially into US policies and EU policies. And after doing this analysis, we went to the social implications of this risk that we face right now with running unsafe crypto systems. What we see is that the US brought these discussions and specifically created cryptography forums to discuss and create algorithms that could be used for the same objectives. So for asymmetric cryptography, how we could phase out of the discrete logarithm challenge to other mathematical challenges. And we saw this in White House directives. We saw it in the Preparedness Act. And this was very interesting for us. This report showed something that all of us already knew, is how, for example, NIST standardization projects are essential to create these new standards, and how we need to apply these new standards that have been discussed for the past 10 years already. And when we moved to the EU policies, we saw a good example on how these kinds of recommendations and policies evolve. So they started with the recommendation from the Commission to orient the countries to create their national programs, leveraging the coordination and the governance capable forums inside the EU. And they decided on the deadline of being PQC ready by 2030. And like, this is tomorrow. especially when we discuss, for example, the DNS, where the processes take time and the shift takes time too. And something that we also saw in the documents is how France, Germany, the Netherlands showed like strong national commitment and started to bring documents. They created the national strategies and started to work on this. And we saw the international alignment of, for example, searching for partnerships in the US and NATO. And so the question here with this work is the DNS secure? And for this, I'll have a friend that will dive into this. But just saying no, and that transition is necessary. And the details I will leave for them to discuss. And the recommendations of our research come really together with the recommendations that Benoit highlighted when he spoke, that we need to prepare cryptographic inventory, we need regulatory support, and we need a global coordination, because no one here works in silos anymore, especially when we talk about internet. And during the transition, we need hybrid systems compatibility, we need a phased migration, and we need to guarantee interoperability, which is very crucial. So the future challenges we have saw that we will have increasing operational costs to do this change. We definitely need to look over the interoperability. We need to take into account a possible quantum divide where countries or organizations won't switch in the same timeline as other more prepared organizations. And we definitely need to think of the environmental impact too, because these protocols use more energy and some of the devices won't be capable of doing this migration and they will need to be replaced. And we have a limited time. And for that, I would finalize my presentation just showing a part of a G7 report. We were talking a couple of minutes ago. This report is from last month, and they state that they plan on starting migration in 2027, next year. And this is a huge deal because there's a lot of work to do, and we have very short deadlines before the next breakthrough. So yeah, that was what I wanted to say. Thank you. And yeah, back to you, Walt.
Thank you, João. Thank you, shown what we've done, what the challenge is, and what we should be doing in the near future. Thank you very much. The next speaker, Santosh Balakrishnan, is Head of Research and Development Partnerships at AFNIC. And he will give an introduction on the PQC implications for the DNS. So, Santosh, the floor is yours.
Thank you, Wood. Thank you, João, for giving me the introduction for my presentation. My name is Santosh Balakrishnan, and I am also part of AFNIC. And today I will be presenting very introductory part of about how PQC has implications for the DNS ecosystem. So I'm not going into details because I have only 10 minutes. The idea is to give an introduction about why we need PQC, then go into the impacts of PQC on the DNS ecosystem and why we need to have this webinar. So let me go into the basics. Most internet communications are based on asymmetric cryptography. So when we say asymmetric cryptography, it is a cryptography based on public and private key pair. Let's say Alice wants to communicate with Bob on the public internet for the secured communication. She has to use the public key of Bob, which Bob has, you see the green lock, which Bob has already published on the internet. Anybody can access to this public key. So Alice, what she does is that she encrypts the message with the public key of Bob and sends it on the internet. Only Bob can read the message because he has a private key in his vault. Nobody has access to this private key, and Bob is able to read that. So this type of asymmetric cryptography is based on different algorithms, and one of the prominent one is RSA. So let's take the example of RSA. I will go into a little bit into the details, but not mathematical things and all. It's not the importance, but just to show that RSA's security relies on the difficulty of prime factorization. So, for example, let's take the number 21. 21, we know it is based on 3 and 7, P and Q. So it's easy for somebody to understand 21 is P and Q is based on 3 and 7. But with the P and Q, when it is accessible, it will be easy to reconstruct the private key. But RSA is 2048-bit numbers. So it's 617 digits long. And it is very hard for a classical computer today to identify that P and Q. It can take years. So that is why for this asymmetric cryptography, RSA is used. But theory says that, literature says that quantum computing running Shor's algorithm will be able to factor this in the P and Q in hours and days. So that means anything that is signed with RSA could be broken by quantum. So there is a quantum threat. So should we prepare for the quantum threat? I have a slide here about McKinsey Digital, which says that how the industry should get prepared for the quantum threat. So here you have the short and long life. But earlier, Benoit talked about store now, decrypt later. So we call it also as harvest now, decrypt later. So what happens is that we all know that quantum is not for next 10 or 15 years, for that is publicly accessible. But what an attacker can do is that he can store data that have long life, for example, like health data, public sector data, banking data, insurance data, and decrypt it later when the quantum computers become accessible. So that is the issue of harvest now and decrypt later. So in order to mitigate this threat, the researchers have come up with the idea of post-quantum cryptography, where Joe has already explained to that. So in this post-quantum cryptography, you have new algorithms that can be working with the classical computers now to mitigate the quantum attacks like the harvest now and decrypt later. So let's get into the prism of DNS. And when you get into the prism of DNSSEC, so DNSSEC currently uses algorithms like Paracel, and organizations like NIST have come with post-quantum cryptography algorithms like MIO, Sphinx, etc. But the problem with this type of algorithm is that they are much larger. So when they are much larger, you have bigger DNS key and RRC records. So the impact on the infrastructure is that you have higher validation overload and resolvers when validating. Key rollovers takes time, more complex, and hardware security modules, which are currently now working only with RSA and ECC, they need to get upgraded. Signing softwares, DNS softwares need to also support the new PKC algorithms. So there is an impact on the DNSSEC, as we say. Is it only limited to DNSSEC? No. There is a broader impact on the DNS ecosystem. For example, if we see zone transfers, transport security like DNS over HTTPS, DNS over TLS, and communication between registry and registrars, which uses protocols like EPP, RDAP, or uses TLS. And TLS also have asymmetric cryptography involved. So as a DNS system as a whole, it has an impact, and PQC algorithms need to be added. Now let's see who is involved in working on PQC. There are a number of actors involved, but let's go to the idea, which is the Internet Engineering Task Force, which works on different standardization activities related to internet protocols, and cryptography. So the idea is there is an exhaustive list. We cannot go into the exhaustive list, but I'm just focusing on certain drafts that becomes future standards on the idea. For example, from a TLS perspective, there are also the mechanisms that are being proposed to mitigate that harvest first decrypt. So is it possible to do that with replacing RSA or to have hybridization possibilities that are being studied? In the case of DNSSEC, we have two tracks. One which focuses on the applications, performance, measurements, key size, etc. And the second draft, which is the PQC strategy for DNSSEC, which tries to look at what are the impacts for the operators like root zone operators, GA registries like AFNIC and registrars. So what are the impacts that could happen? So these are some works that have already been going on at the IETF, and there are other works which I have not shown out here. So what we understand is that there is an issue, and with even though we know that it might not be there in the coming 5 years content, but quantum computing might be accessible to the normal people in 10, 50, 20 years. We never know. So why do we need the PQC webinar? So the PQC webinar is that we know that quantum is eventually coming and RSA and ECC could be broken. That means the cryptographic backbone of the internet becomes vulnerable. So even if the quantum arrives in 10 to 20 years, the data stolen today still be sensitive that attackers can record. Encrypted traffic today, store it and decrypt it in future. So this affects like government, communications, healthcare records, legal archives, etc. So as we have seen, PQC affects the entire DNS ecosystem. So should be prepared. It is important, as Pierre said, IPv6 and all. We should be prepared earlier to reduce operational risks. So if you wait until quantum computers are practical, transition becomes chaotic. Early preparation means gradual testing, hybrid communication, community alignment, etc. So the webinar goal is to align operational communities, involve all stakeholders, not only from the DNS ecosystem, you're also thinking about routing. So we think that educate and coordination are essential to understand the impacts, standards, and enable the path to a safe quantum transition.
Thank you, Sandosh. I think you've stated the challenge that the DNS layer of the internet faces is large, if not to say huge. We're also talking about the routing layer of the internet. So I'm going to give the word to Nicolas Fiumarelli. Nicolas is a senior software developer at LACNIC, but today he represents ISOC Uruguay, and where he's a board member. He's also the chair of ISCC Working Group on IoT and co-author of the Working Group 9 report on post-quantum. Nico will go deeper into the technical implications of the transition, focusing on routing. Nico, the floor is yours.
Thank you so much, Wout. Very happy to be here. Thank you for the opportunity. We are seeing today routing security in a post-quantum world. Let's go a little about it. I will be very rapidly, so we'll avoid and skip the part of encryption, at least two parts that I will mention. Then to focus, also skipping a little about post-quantum encryption algorithm, and at the end about routing. That is important of my presentation. Very short presentation of myself, as Wout said. Also working on the steering committee member in Manners, and Internet Governance Forum in my national country and the youth, and then the software engineer at LACNIC. Different algorithms we have seen in terms of encryption within the evolution. Joao mentioned about the Caesar cipher. There were also the Vigenère cipher. Then you have different ones like the Enigma machine in the Second War. And then we came to RSA and AES, right? RSA is the Rives Shamir Andelman. We know that it's good to talk about the complexity order. It's a term in mathematics. Is in the case of RSA is 2 raised to the power of n, is exponential. And here is the example, as Sandosh mentioned, Alice and Bob wants to communicate, public key, private key, and you multiply this prime number. That is what we were taught when we were at school on these prime numbers. Very important for computer sciences. And then you encrypt the message, and with the correct key, you decrypt the message.
But with what happened with the quantum computing, you have these classical algorithms, but with quantum computers, the Shor's algorithm and Grover algorithms, as Joao explained, will amplify this attack, is exponentially gaining. So we came from an algorithm that is 2 raised to the power of n, that is exponential, to an algorithm that is potential or polynomial, right? Is n to the cube raised to 3. So it's very, very easy to decrypt using short, but you need larger quantum computers, obviously. The other one is AES, that is also weakened with quantum computer because it's the half. So for example, if you use AES 2056 with Grover algorithm, a sufficiently large quantum computer and with fiability as well, you will reduce the complexity to the half. It's like having half of the size of the key. So in this case, AES 256 becomes to 128. So it's good to be migrating to 512. That is the other one. So you have a double the ability to protect from quantum computers. And AES is very common use in WhatsApp, Signal, this kind of messaging apps, what the RSA is using, HTTPS, domain name systems, and the other. So quantum computer came, we have examples of real quantum computers nowadays. There was, the last one is Quantinuum from last year in November. They were doing enormous efforts in having how much physical qubits you need for the logical qubits. Now 2-1 is the relation, so it's enormous advancements. And you have Google Sycamore, IBM, roadmaps, and different ones. So it's not theoretical. NIST News, as mentioned, also you have different algorithms. The NIST spokesperson, Dustin Moody, emphasized on transitioning. There is no need to wait for future standards. Let's use these ones that we know they are useful, and with test beds over more than 5 years, so the transition will happen. And this is not the situation we are covering, right? RPKI is Resource Public Infrastructure, is the algorithm, the protocol used for Protect BGP. Actually, that is a routing protocol. And there were situations in the past where there was a need, obviously, because of these internet protocols that were not secured in the beginning. So route hijacking is one of the kind of attacks people can do, or unintentionally, or sometimes is intentional. In this case, was unintentional. It was one of the first cases of route hijacking in the Pakistan YouTube Telecom outage, because they announced that they were YouTube. On one side, you have the IP addresses, and the other is the domain name. When you want to access Google, you need to know who is google.com. You have the DNS service, and you have the IP address that is like that number, 208.65, etc. Then on the other side, you need to know how to route this information through the internet. This is where to go for this IP address. So you go there, the routers are communicated, have the routing table, but they can lie, right? With the DNS, it's the same. You say, oh, I am Google. No, but you are not Google. You need to see the sign. This is signed. You need to use cryptography to check. When the routing is the same, you need BGP announcement. This is my autonomous system. Autonomous system is like a network. It's like a set of different IP addresses that can be reachable there. So you route information through autonomous system, but a rogue autonomous system can tell that, in the case of Pakistan Telecom, that they are YouTube. So all the traffic goes through Pakistan Telecom, thinking that there is YouTube there. So to prevent BGP hijacking, you have here some technologies like RPKI, Route Origin Validation, or BGP-SEC. There is another one nowadays that is ASPA. Let's talk later about that. So the state-of-the-art of routing security is that you have the regional registry that are the owners of the IP addresses assigned by the IANA from ICANN, right? And then you have the IP addresses, and the IP addresses are distributed in the regional registries, and the regional registry are assigned to the ISPs and the cloud service provider. And these networks of the ISPs are the ones that need to say, okay, I am the owner of these IP addresses, let's sign this with a ROA. ROA is the object of route origin validation. It's a signed object that states which autonomous system can originate these IP addresses. So that is a way, if you have a routing validation, you take from the regional registry repository these cryptographic objects, and then you can validate in your network if the announcements of other networks are correct or they are been adulterated. So that is thousands of operators publish their ROAS. We have reached more than 60% of BGP announcement covered by ROAS. So it's a very good advancement. You have manners, you have different groups of network operators. And what happens? The NIST launched these 3 algorithms, Kyber, Deletion, and MSFix. I will not enter in the mathematical details, but if you remember, RSA was 2 raised to the power of n. So now we have 2 raised to the power of n multiplied by the logarithm of n. It's a little stronger. It's not more on prime numbers. Now it's on lattice based. It's like a matrix, multidimensional matrices, and you add errors. So it's very, very strong. You have Kyber, Dilithium, and others that are now available nowadays in cryptographic suites. And here is an explanation of the formula, etc. Alice and Bohm can interact in this way. And what happened? Similar to DNSSEC mentioned by Santosh, RPKI has the certificates and the ROAS have a size. We are saying we have 60% of the BGP announcement covered by ROAS. This is a lot of information. Imagine if you double or triple the size key, and also to cipher these algorithms is complicated. But there are test beds. The situation of the photos is not the one that you will see because this is already being tested in the industry. There are hardware optimizations and everything for you to be able to get with this transition. But yes, certainly RSA and ACDSA are not going to be the future standards. And what's happening in the IETF, we have the PQUIP, that is the mother of all roadmap or transition for PQC in the Internet Engineering Task Force. And then you have migration use cases. That is a very good example of draft that talk about hybrid formats, how to ensure backward compatibility. And there are several working groups working on that, like the TLS and mentioned on the others. And especially the LAMPS working group defines the certificates that are used in the RPKI, the routing. There is the X509 PQC certificates. They are working in the PQC using the Dilithium, that is one of the NIST, and they are adult. So now RPKI can advance this draft on adopt new PQC signature formats. So this is under construction. DNS is more advanced than the routing right now, but this is going to be updated, and there is a roadmap that in the middle 20s, there is testing in the middle 20s, sorry. So it already been passed. So we are coming into production to have RAW signed in regional registries for the early 2030s. And what about the rest of the industry? And I am very honored that some of the authors of these graphs is in the meeting here. Is the other Santosh. And he works in advancing DNSSEC, especially with PQC. And there is good news that the operating systems and browsers, the majority are ready, like PQ ready. But being PQ ready is not that you will be sufficiently secure. It depends on the ecosystem, right? It depends if the networks are using the cipher. So it is a full ecosystem that we need to go within this transition. But there are real examples that Gmail and others that already have a PQC ready in the DNS and in other cryptographic like TLS.
Nico, sorry, you only have 1 minute left.
Exactly. Thank you. And this is my last slide. So the figure for the future, in my personal opinion here, is that on one side, we need to have this robustness of networks, use SSH servers with PQC, DNS, and all in the different parts of the critical internet ecosystem. And that way, we can be, with these risks, really minimized. You know, the harvest now, decrypt later. This is really happening. And also the supply chain in the case of IoT devices. So that is from my part. Sorry for the technical. And if you have any question, very welcome. Thank you.
Thank you very much, Nicolas. As Nicolas says at the end, it's time for questions. Who would like to ask a question first?
Name is Peter Olsen, based in Bergen, and daytime security consultant and spare time trying to fix the internet. I do speak to a lot of banking customers in my daytime job, and they are starting to ask questions now about PQC. They all refer to the banking authorities in the European Union about PQC, something that we need to have in place somewhere between 2030 and 2035. And I'm telling them we can give you PQC already today. We do have support for that in some of our front end, like F5 big IP, reverse proxy cache boxes as an example. And then they say, no. We do as the European government is telling us, so we will do this in 2035. Are there any opinions on if we can offer PQC, how can we actually convince customers to start using it now because it is actually already available?
Who would like to answer? Santosh.
I can take your question, but I would say that I don't have authoritative information.
That's why.
I don't work for banking, but we did have contacts from banks that wanted to, from a DNS perspective, for example, from DNSSEC, they wanted to start doing some proof of concept based upon the European directive. And they were also interested in the hardware security modules that need to get upgraded. So there had been some discussions, but since we don't have internal details and I don't have the expertise on that, I cannot authoritatively say, but as you say, they've started looking at it and they are looking at it from a DNS perspective also.
Okay.
If I may, but in addition to what Sandra said, like for instance in France, you have security qualification required for some security services and products. So in the scope of the bank IT assets, if some of them are just simply have the need for qualification, if they are running unqualified softwares, for instance, I think it could be two issues for sure.
Thank you, Benoit. And I see Dimitri in the chat saying that banks will follow regulations and regulations follow law. And there are EU efforts from the FCA. If you would like to elaborate on that, Dimitri, and then I'll come to you, Tahar.
Yeah, so my name is Dimitri Furness. I started the company in the field of PQC back in 2023. From before that, I started working at ABN AMRO in 2018, creating the quantum program. So then we jumped into this ecosystem, but the security part was the most important. And I've been talking to a lot of banks lately and also regulators to see, what would trigger a bank to start using PQC? And the answer is just regulation. Because, within the Netherlands, when a bank is using something that's not regulated and something goes wrong, the CISO goes to jail. And if you're using regulated stuff and something goes wrong, nothing happens to the CISO. And banks are very risk averse. So it's kind of like, okay, we need to have these regulations. But then I'm in regular conversations with the FCA. The FCA has started something with the World Economic Forum to get different regulators together internationally. But the FCA is waiting for law. But then within Europe, Brussels is waiting for member states and member states are waiting for Brussels. So that's the challenge we have in Europe. And until we get this done and start somewhere and have someone to start bringing out stuff, nothing will happen. So that's our challenge. And that's what we need to highlight and express within, I think, not only the banking, but every critical infrastructure. Routing and DNS is part of critical infrastructures. So also those kind of environments, when certain organizations are liable for certain things, we need this regulation. So that's something we should target.
Thank you, Dimitri. I think that makes a lot of sense. The question is, will it ever happen voluntarily? If we look at the other, IPv6 was an example, but DNS is an example, routing, RPKI is an example, etc. I see a question of Tahar. You're first in line, and please introduce yourself first.
Okay, my name is Tahar Shah, a long-time RIPE fellow, made some policies some time ago, worked a lot for German government, Ministry of Interior, and currently starting to deal with post-quantum cryptography to get a doctor about it. So one thing on this regulation stuff, the BSI in Germany is starting to recommend it heavily to introduce PQC algorithms. And perhaps it's an idea to say, okay, you have a lifetime of your products. Think about when you have to introduce to have PQC in your products in time, in place, when the regulators will recommend, and not only recommend but force it to use. This is one way to go.
Santosh, would you like to respond?
Yeah, I would like to add what Tasha said, that the discussions that we had, I just recollected it was from the payment cards industry, digital security standards, I think DSS 4.0, the European Commission, European Union has some directives on that, and they were interested based on DNS and post-quantum. I just wanted to add to what Tasha said.
Yes, thank you. And what I personally would like to add, what always surprises me, that you have the economic buying power of companies. So why are they not demanding security by design when they procure their ICTs? And that is the one that boggles me, that they always wait for legislation that may never come. So in other words, what are we waiting for? I see another hand up, Raul.
I'm Raul Carey from Congratulations for this initiative. And only to comment that we are working on a measurements group, and we intend to include measurements about banking readiness for PQC in Latin America with Nico and another colleagues. So very excited to include this, and thank you for this opportunity to hear the presentations.
You're very welcome, and thank you very much for joining. Romel, you're next in my line, so please introduce yourself.
Hi, I'm Dr. Romela Janine of Lucid Pattern, newly formed AI consulting company. So my question basically is around the risks of fragmentation. In particular, are there certain signs where maybe certain countries are looking at different algorithms, and is there an attempt to try and get, or has that already happened, a set of like standardized, if you will, set of preferred algorithms that can be used? More the geopolitics of this going forward, I would appreciate hearing more about. And thank you so much for the presentations and this panel.
You're welcome. Who would like to answer the question?
I can go with this one. Thank you for the question. So what we saw in our report, in our research, is that the world is divided. It's divided by two. So there is a group that are looking to the nest and seeing what are being standardized there, and the other half isn't looking anywhere. So the challenge that we are facing here is to really look into what NIST is doing, and no one is trying to run in another way of creating their own post-quantum standards.
Thank you, Joao. And maybe there are people not telling anything, like in some countries perhaps, but we'll find out later. I see Paul Hoffman's hand is up. I'll take that as a final question before we move into the next session.
Hi, my name's Paul Hoffman. I wear many hats, but I'm the chair of the PQIP working group in the IETF that was mentioned earlier. The only reason I raised my hand was not to ask a question, but to disagree with what Joao just said. There is another group that is looking at their own algorithms, and that's in Europe. And in specific, they are looking at signature algorithms that are different than the NIST algorithms. And that is causing a lot of problems with people thinking, because it's one thing to say, oh, I need to change my TLS software because an algorithm changed. That's much easier than changing signatures because you have the whole trust chain and such like that. And that's one of the reasons that things are going slowly right now, is that in fact, there isn't agreement on that. And as a side thing on picking an algorithm, as a few speakers mentioned earlier, there is also the question of, will we go with a PQC algorithm, or will we go with a hybrid algorithm? And again, for signatures, this causes a problem, because once you pick a thing and the slowest, most important people at the top of the chain pick it, then changing your mind later means everyone re-signing something. So to answer the question about this, yes, lots of people are looking at this, and that's why we don't actually have almost any direction at this point about signatures, even though we have very strong direction about encryption. Thank you.
Thank you very much, Paul. Would you like to respond, Joao, before we continue?
Would love to see the work of this group, just to understand what is, because when I read the recommendations from the EU, they didn't cite this, but yeah, I don't know how in the timeline these events happen.
Okay. Thank you, and thank you, Paul. What I would like to add to this is just look a little bit at the future, what we plan to do with this project in the coming 2 years. We've heard these concerns voiced, we heard the challenges that were identified, we discussed consequences and potential solutions were suggested. But when we look at things today, there are two things are certain. Billions of research money are being invested in the development of quantum computers. The OECD mentioned something like $55 billion in 2025. And a quantum computer will be able to break all current security algorithms. When I was at a webinar of the OECD recently, the Danish, UK, Canadian government representative mentioned that the first quantum products are about to go to market. I put that to a Dutch university person. He said, we in the whole Netherlands are already doing that in 3 different ways. But the most important that he mentioned was forgot the word, sorry. I'll get back to it. So many people agree that fully operating quantum computer is at a minimum a decade, if not further away. However, to state that it's not necessary to act now on post-quantum cryptography is the equivalent of the fabled ostrich hiding from danger. And why is that? On the one hand, a major breakthrough could be one eureka moment away, while on the other time we waste valuable time. So not acting today is like what happened in the movie Don't Look Up, if you saw it, where a comet is heading towards Earth and people pretend there's nothing happening just as long as you not look at the sky. But to avert catastrophe, we'll have to make timely and coordinated actions by many different stakeholders. In an ICT, there's only one example at this point in time where joint agreed upon and coordinated action actually worked, and that was the Y2K bug. And I'm convinced that we are in such a situation today. To focus solely on the commercial rollout of quantum computers overlooks 2 factors. And one is to break current algorithms with enough power is easy. And 2, researchers are already combining current computers with quantum. And what if the eureka moment comes from there first? And on top of that, what if a rogue actor that have billions to play with as well at this point in time will deploy this power first? So we have no time to lose. Why is that? Because ahead of us lies a gargantuan task. Those involved will have to agree on which standards to use, to convince all stakeholders to act, and to make PQC the new standards, while at the same time deploying the current ones that have not been deployed optimally already. So the underlying standards have to be up to date as well. And let's face it, the deployment of standards is not something the ICT world is good at. And nor, as already mentioned, procuring ICT by design is not something procurement officers of a public and private organizations are good at. All this has to change in the coming few years, and that includes a change in attitude and mentality to developing, manufacturing, offering, and procuring ICTs. So how can we progress? This project will work on exactly this topic. We plan to instate 2 working groups, one on the DNS and one on the routing layer of the internet. But why these? Because as you heard today from Afnik, there is support for this work from the internet technical community responsible for these 2 topics. And the working groups are filled with experts from the technical community and academia, and we may some other stakeholders over time as well. And if we manage to create a roadmap, it also becomes possible to make it generic, so we can involve other players from that point in time as well. So what will these working groups do? What will be their tasks? First is to map the landscape of quantum-ready proposals and standards relevant to each layer. Second, assess migration options and identify the major challenges for these 2 layers. C, produce actionable guidance for a timely, safe transition and to prepare phased roadmaps. Fourth, coordinate globally with operators, vendors, standards bodies, etc., etc. So we will get everybody to move at the right time. Fifth, to advise different stakeholder groups on call for action that will ensure and aid the PQC transition. And finally, along the way, we do outreach to raise awareness at each step. That's why we invite experts to join these working groups. And in the chat, I will present the option where you can send an application to, which happens to be me in this case. But you can join these working groups and indicate your interest now, or you can contact us later after the webinar. The idea is that this work will be carried out in 2026 and 2027. And in order to be successful, it needs professional support that will be responsible for the organizational support, the coordination and the reporting of the working groups, and the organization of outreach, presentations, and coordination with different stakeholder groups within the Internet Governance Forum's ecosystem. Because we plan to put these working groups under the aegis of the IGF so that we have a neutral platform where everybody is equal and can discuss at the same level. So for that, we need the support not only of these professionals that will help us create the roadmap, but also we need financial support to pay the professionals who assist in this process. The goal is to present a roadmap in 2027 for the world to act upon that is not only a piece of digital paper, but has general support and ensures follow-up actions. The blueprint of this roadmap will be actionable for similar topics at this discussion and do not stop with PQC for DNS and routing. To start now gives us the chance to be PQC ready when the time is there. The task is gargantuan and it will take many years, so we can't afford to wait. So as I said, experts are invited to join the working group and organizations are invited to financially support this work. And we will be leading this initiative, which is the IS3C. So let's open up for a third round of questions before we have to finish in a few minutes. Amando Razzol, you had your name up, so please ask your question.
Thank you. This is Amado Espinosa, co-chair of the Dynamic Coalition for Data-Driven Healthcare. And my question is, do you foresee in the next future to talk a little bit about the preventions or measurements that we do have to take into account for this post-quantum era? Because at the healthcare environment, a lot of medical IoT are in place. Thanks.
Yes, thank you. I will look at you first because you wrote the IoT part in the report, and perhaps Nico, you would like to answer as well as chair of the IoT working group.
Yeah, so this definitely needs to be looked over since we are taking off constrained devices, and the IETF also is working on this. They have a proposal speaking on PQC4 constrained devices. And yeah, that's it.
Yes, I could add a little about it, that you have different working groups about IoT in the IETF, IoT security, for example, COSE and different ones. And in that sense, signing objects in low power devices and constrained devices is another challenge. So they are working in hybrid algorithms, but also if you think the IoT devices has not sufficient energy and memory, so you are using the cryptography part in the router itself. So it's in the edge. So it's a combination of different signing with the different technologies to have at least one part that is post-quantum ready. That is something that is working at the IETF at this moment.
Well, thank you, Joel. Is there another question? I see Romela, you have your hand up, please.
All right, thank you. So listening to all of this, I'm wondering if there's a need maybe for a third working group who would maybe be tasked with looking at developing overarching communication strategies to recommend a set of potential algorithms. Just throwing that out there is on the fly thought. Because if we have the routing and the DNS groups doing their own thing, are they going to be tasked at advancing what they think is the best algorithms for their particular case? And we definitely understand that we can't really have two sets at the different layers. Just throwing that out there as maybe something to think about at a later date. And to have a set of unified recommendations concerning algorithms for what, and to think about strategies for trying to advance maybe the adoption of those.
Thank you very much, Romela, because I think that is an excellent comment. I see as a possibility, but that is something that I can't decide on my own, but besides the people who will be working with. If we are able to start this work in May and come up with a first interim report in 2026, it will show the direction of where this is going. And by that time, we may be able to advise the Internet Governance Forum's organization called the Multi-Stakeholder Advisory Group to start a policy network on what you are advocating, to make it generic and to make the outcomes available and discussed by all different stakeholder groups. But that is something which is premature at this point in time, I think, because we do not have anything yet. But it's something that we will be discussing in the coming months so that we have a proposal ready, if we are ready by early 2027, to turn this into a proposal for a policy network and then see what happens. Is there somebody else who would like to respond to this question? Santosh, you have your hand up. Is that related?
Yeah. From my personal perspective, I think we don't have the required expertise to tell to the world that these are the algorithms that we should work on. I think there are forums like NIST and other forums that they do have the expertise. What we can do is that we can get information from them, pass on the information as webinar, but not as a group or ourselves suggesting that these are the algorithms that are better than others for specific categories.
Yes, that is why we may be considering to bring everybody in so that the different stakeholders that are now all on a different level, as we understand from Paul's comment also, to start agreeing on what the best way forward is. And the global level, like the IGF, could actually help with creating that roadmap. And after that, whoever wants to start working with it is something that we can never decide on, of course. But that is something we'll be discussing later in the year. First, we have to get this off the ground and make sure that we start working. We have time for a final comment, but perhaps the speakers would like to reflect for in 30 seconds what their takeaway is from this session. So let me start with Benoit. What is your takeaway? And then we'll close in a few minutes.
Yes, thank you, Wout. So I would like also to thank you, especially for the organizing this webinar and planning everything. Also thanking IGF Secretariat for sure as well. A very short takeaway: we should prepare thinking about transitioning and thinking how to transition in a timely manner. That's it.
Thank you. Pierre, what is your takeaway?
My takeaway is that there is a consensus on the fact that we do not to panic, but we need to work from now and steadily to accelerate the transition.
Thank you. Santosh?
From a technical perspective, I think we do have expertise on DNS, but the people participating here were different expertise. For example, I take the example of the bank, where they have the use cases and requirements with respect to DNS or routing. They should also get back so that it could be a give and get policy, and then we have this webinar being used for multiple stakeholders.
Thank you. João?
My takeaway is that when we started this project, we decided to look over the post-quantum cryptography challenge. And in the end of the project, we narrowed down on what we wanted to do first to be our mission. And the result of this mission is that we have these two working groups, the working group on routing and on DNS. And if anyone also thinks that there is another opportunity, they can join forces. We are planning to work on DNS and routing. But if enough people reach and we have expertise to work on another topic, we will do it too.
Thank you. And Nico?
Yes, very short from my part to say that first we need to safeguard the critical internet infrastructure. This is the root zone and the CCTLDs in the case of DNS and the main routing autonomous system. But at the end, this is voluntary, right? And at the end, it's multi-stakeholder. Internet security itself is a huge challenge nowadays. In my country, for example, we don't have DNSSEC in .com.ui. That is the most popular used DNS. And if this is happening, how we are thinking in the post-quantum challenge that we have larger keys. So this is a huge challenge. We need to combine not one part, but everybody. And for the future of the internet, we will have more costs. That is obvious, but this is what we need to do. Thank you.
Thank you very much. I think sums it up nicely that we have this huge challenge. We've picked up 2 topics to start with, but it's quite clear that everything and everybody has to move, because this is not just about the DNS and about routing, but it could end up with a roadmap that makes it possible to start this discussion in a broader way. And hopefully that it is possible to start that in 2027. But for that, we need to start, and that's my summing up, we need to start these 2 working groups, and we have great experts in these working groups already. And we need a few more so that it's more regionally based, but more regionally spread, and that we need funding to be able to pay the people who have to do all the work around these working groups. So if you're interested in joining the working groups, please sign up. I'm sending the information once again. If you think your organization is able to fund us in one way or another, then please do reach out also, because that is the way that this work is going to take off the ground. And as I said, we will be working in a neutral environment underneath the IGF, and that will make it possible to make great strides, and in a more easy way perhaps than if you're in a political environment or in a siloed environment. So let me stop there. I see very encouraging messages in the chat. So thank you all for participating. That is the start, but also thank you for our 5 speakers, Pierre, Benoit, Nico, Sandosh, and Joao. And okay, myself a little bit also. But we're going to do 2 more webinars on this topic. The first will be on the DNS, and that will be on Wednesday, 18th of March at 1300 UTC. We will be sharing a link again through the IGF Secretariat very soon so that you can sign up for that topic. And on Thursday, the 2nd of April, we do the workshop on the routing and PQC, and we will be sharing that pretty soon also. So finally, the IGF Secretariat, thank you very much for so kindly hosting this webinar and making it possible. And I wish you all a very good day and a very good afternoon. And thank you for attending and your interest and your interesting questions. So have a good day. Bye-bye.